Hi everyone, today I drive the elongation of tapered circular bar. Let's see how we derive the elongation of tapered bar. Elongation of tapered circular bar. Let's see how to drive its formula. The elongation of tapered bar is 4pl by pi e del 1 into del 2. This is your expression which which you get after the after drive this for this tapered bar. This is our result when you drive, when you complete our derivation. After at last we get this formula. Let's see how we'll drive this. First we have to consider a tapered circular bar. What type of bar is called tapered circular bar? Let's see. I'm going to draw the tapered circular bar. This type of bar is called tapered circular bar. We have two diameter, that is diameter at section at A, this is, and at B. This is your diameter D1 and this is D2. And the force is acting in this end. Let's see. And its total length is L. Length of tapered bar is L. And the force acting in this tapered bar is, let P. P is your force. This is your diameter. Let's see. Let's take a small section in between, anywhere between this section, this bar. I assumed there is a small section whose diameter is dx and its length is a small dx. Let's assume this is x is at 0, and if you go slowly increasing the length, at that position x is become L, and this section, we cut this section at position somewhere at distance of x from A. So let's see. First we draw this section here. This is your section. We take in tapered circular bar. Its diameter is dx and its length is dx, and force acting in this is same as this tapered bar, P. Let's first find the area of this bar. What is the area of this bar, of this small portion? That is, this is in circular form. So what is the formula of, what is the area of circumference? That is pi d square by 4. So this is pi, and what is the diameter? Diameter is dx. Dx is diameter, which is a square of d square by 4. This is our area of this portion. And what is the formula of elongation? We studied previously. What is the formula of del L? That means, it means elongation. What is the formula of elongation? Force into original length upon into elasticity. A means area, Young's and E means elasticity. Yes. What we write there? What after calculating, if we put here A is equal to pi by 4 d square, it means it's 4, it's 4 multiple, it's 4 go upward. So we write this 4 and P is P, and what is the length? What is the length? Length of this person is dx. So we write instead of L is into dx upon what is area? Pi dx square into E. Then similarly we write this equation as first P dx upon pi E dx square. Consider this as equation first. Now let dx is equal to d1 plus x dx. This dx is equal to this this diameter plus what is the distance, at what distance of this diameter is lie, at distance of x. So we write this at L, at point, this point, at point L, what we write? What is your diameter at point L? d2 minus d1. So at point first, at 1 meter, this is diameter at length L. If you find what at 1 meter, what we get the diameter? d2 minus d1 upon L. This is rate of change of diameter at, then what is then rate of change of diameter at x is equal to, x become, what is the diameter at x point? This is a point at 1 meter, and what we get, what we find, where we find the diameter at point x. So at where we find the what is the diameter at point x? d2 minus d1 upon L into x. At this point we will find the diameter of x. Thus dx becomes d1 plus this x, this value of x is put in equation 1, then equation 1 become equation, not equation, in this value instead of in this equation. So this dx becomes d2 minus d1 upon L into x. Let's consider this as equation second. Let's check the equation is correct or not. Check the equation. Check the equation. Our what we find, this equation will be correct or not. Let's check. At x is equal to 0. If we put x is equal to 0, it means we find d1 diameter. Let's put x is equal to 0. If you put x is equal to 0, in this case there is d is equal to d1. It means this equation is correct. Dx equal to d1. This will be correct. Let's again check. Dx become L. If you put L, it means there is a d2 this diameter. Let's see what will get after putting L. Dx is equal to d1 plus d2 minus d1 upon L into L. This will be cancel out, and this will be also cancel out, and thus we get dx is equal to d2. Hence our equation will be correct. Now again, now dx is equal to d1 plus d2 minus d1 upon L into x. Let k is equal to d2 minus d1 upon L. Let this x is d2 minus d1 by L is equal to x. Then dx become d1 plus kx. Putting this value in equation first. Then what we will get? Elongation. After putting this dx value of dx in equation 1, let's see what we will get. Del L is become 4p dx upon pi e into d1 plus kx all square. By integrating, let's integrate both sides. After integrating this side, what we find? We find the total elongation. Then we integrate this 0 to total integration dr, and this will we integrate the total length according to lengthwise. This is 0 and this is what is the length of total length of tapered bar L. So we integrate this portion is 0 to L. Then 4p dx upon pi e d1 plus kx all square. Let's see what we will get. We'll get this LT after integrating this. Now 4p upon a is constant, so this value will be right this side, and we have to integrate only this portion. Dx upon d1 plus kx square. 4p upon a, after integrating we will get what we will get d1 plus kx upon minus 2 plus 1 minus 2 plus 1. After integrating we will get this value into and this differentiation will be by x. 0 to L minus 4 p upon pi e, and this k is also constant, so we write this k here. We write this k outside of this bracket. So what we will get d1 plus kx power minus 1. What is the integrating? 0 to L. Now see, minus 4 upon pi e k integrator d1 plus kx or minus 1 and integration 0 to L. What we will get? There is minus 1, then we write this in dominant. We write in a reciprocal form. So if you write this like in numerator and denominator form, then we write this and then it become positive sign. If you write in this in numerator form, then it become positive. Yeah. Minus 4p upon pi e k 1 upon 1 plus kx. This become positive. This power is positive, and 0 to L. Minus 4p upon pi e k. After solving this, we will get d1 plus k, and we put instead of x we put first L, then minus we put instead of x is 0, then it becomes 0, there is only d1. So 4p upon minus 4p upon pi e, what will get the value of x? We let the value of x is what we let the value of x. What is the value of x? We let the value of x. Here is value of x is d2 minus d1 minus L by upon L. So we put this value here, d2 minus d1 upon L, and 1 upon d1 plus kl minus 1 by dl, d1 minus 4, this L goes upper part, so 4pl upon pi e d2 minus d1, and instead of this d1 plus kl, we similarly, because this portion is L, so we write instead of this is 1 by d2 minus 1 upon d1 minus 4 pl upon pi e d2 minus d1 into d1 minus d2 upon d1 into d2. After taking here minus sign, we will get minus minus positive, minus 4pl upon pi e d2 minus d1, and we take minus negative common, and then this become d2 minus d1 upon d1 into d2. This become cancel out, and this minus become positive, and finally we get dt is equal to 4pl upon pi e d1 into d2. This is our required equation. Hence we proved the elongation of tapered circular bar. This is our required equation.